Hello all, welcome back to Research and Researchers Talk by Rasmita. I hope you all are doing well. Thank you for all your support and comments for the last video. Please share with the fellow researchers and the upcoming students. I hope these videos will motivate more students to opt research as career option and the existing researchers will be inspired by the discussions. So today we are going to discuss on a new topic, research and career in polymer science. So most of us knows polymer science is a branch of science and a multidisciplinary subject included in physics, chemistry, and engineering. Like we know, polymers are the macromolecules which is formed by the chemical bonding of large number of smaller molecules and the repeating units called monomers. Of course, those who don't know about the polymer chemistry, but they know they're using polymers in the day-to-day life, as in the clothing, fiberglass, plastic bags, in the automobile industry, the bearing, polyethylene caulks, epoxy glues, silicon hard valves, Teflon cookwares, and there are so many adhesives, even in the paint industry. So scientists and researchers keep on improving these materials by their studies and research in order to develop some sustainable materials with the finest product. We should know how to become a polymer scientist or how you can choose the polymer science as one of your career options. Let's discuss with one of the outstanding researcher or the polymer scientist who has several years of academic and industrial research experience in the field of polymer science, Dr. Srijita Purakasta. I'm welcoming her to this discussion. She has completed her PhD from Indian Institute of Technology, Delhi. Prior to joining IIT, she obtained her bachelor in engineering and master's in technology, both in the polymer science. So let's discuss with her about her journey, how she was preparing herself to become a polymer scientist, and we'll know her experience in the polymer science research or what polymer scientists are doing, we will know from her. And most importantly, what are the career options? So let's welcome Dr. Srijita. Dr. Srijita, please tell us something about yourself.
First of all, thank you, Dr. Rashmita, for calling me for this discussion session. Whatever I know, I would like to just share with you, and I guess that will directly or indirectly will give some thought to the new students who are coming to polymer field. So I have done up to my 12th standard. I have done my studies in Tripura, that is my hometown, and then by clearing Tripura JE, I came to SJC Mysore, which comes under VTU, Vishweshwaraya Technological University, Karnataka. I did my engineering in polymer science and technology. That time I got the job opportunity in a master batch industry, which was based in Pune. So I worked as an associate marketing for 1 year. By that time, one more time I wrote GATE and I cleared it, and I got option of IIT Delhi, IIT Kharagpur and IIT Mumbai. Then only that time only IIT Delhi was providing core polymer MTech course. So with that thought, I joined IIT Delhi. I completed my and I continued my PhD journey also in IIT Delhi, and I finished it in the January of this year. So after then, I worked as a postdoctoral research fellow in a paint company.
What motivates you to become a polymer scientist, or why you have chosen to study polymer science?
Polymer is something like, the generation is changing. The way there was a metal time, there was a glass and everything, like from stone age to metal age, and then the new era is polymer. So that time I guess I cleared it in 2008-9. So that time it was not very common. It was in a starting phase. So people were not very much aware while doing engineering. So the reason behind that was like something exploring a new field. So that was the reason. And as the college was very good where I was getting the seat, so both of these things worked together and I have joined for the engineering program. Actually, I did not go for any coaching and all. I had the basic idea about throughout my engineering. So that is like my idea, or that is my view. We should have a very clear understanding of basics, whatever it is the subject, whether it is a polymer or whether it is a basic science or any part of engineering. And I just like to mention 2 points. One is, yeah, throughout your engineering, your basics should be very clear. Whatever you are learning, it should not be only for marks. The other thing is, I went through the question papers of like last 10 years, and I saw what kind of questions they were asking again and again. And if you study very properly, you will get to know there is a trend. Like, there is no one is asking you to write a 2 page chapter or 2 page answer. So people are asking like optional question in the gate exam. So I guess this analysis also helped me a lot while clearing the gate.
That will be very good guidance. Okay, next. What motivates you to leave the job and move to the research profession? And why only polymer science, not other subjects? ठीक है?
Yeah, so
क्योंकि मुझे
it was an on-campus job opportunity, so I did not want to leave that option. So I thought it is better to once see how the industry works. And after joining, what I felt more than as my role was as an associate marketing, I felt more than the commercial road, I would like to pursue my career in technical role. So that was the reason of going for higher studies like MTech and PhD. So
choose polymer science. Like from the periods you told that like after your 12th you have joined the BTech. That's fine for the polymer science because after BTech you have so many options like you have plastic engineering, you have rubber technology, you can also join to the chemical engineering. Then why you choose polymer science?
in that case, I would like to give another side of my view. I feel bachelor's, any kind of bachelor's degree, give you just the base of any education when we talk about higher education. But when we go for masters, doing masters mean you are mastering a particular subject. So in masters, no one is teaching you the basics. We already knew the basics and we are mastering in the technology. So like if we go for another even I had this discussion with my supervisors as well, like my engineering supervisor, and then we decided that it is better to continue the education in the same field, but I can explore more of the topics, I can cover more of the topics. But always the masters and PhD, it is something like you are becoming expert and expert in a particular topic. Engineering gives us the option to know what all options I can choose, which topic or which subject is of my interest. So that helps.
That was a good point. So, like now, what is the area of research when you're during your PhD or MTech? What is the particular? Because polymer science is a broad field. Like what you have chosen to carry forward your research?
I had done throughout my engineering, MTech and PhD. Somehow my research were always inclined towards environmental factor. I guess that is my inner thought. I always wanted to make something which is environmental friendly, which can be used in the society, not like doing research and keeping it in the cupboard, the data. So in that case, my engineering project was about the pyrolysis of commingled plastic. So I have prepared a reactor and we have done this work. So the purpose was to reuse the plastic waste. So that was the building block of my first topic during engineering. During MTech, again the topic was towards inclined to environmental, as I mentioned. Multi-layer film packaging, it is a big threat for the society. When we like to dispose it, differentiating or taking out all the layers is a very big
Sorry
task.
to interrupt. Can you please explain a little bit in detail, like what is that thing? How it is a threat for the society, just in the simple language, so that other people can understand apart from those who are not in the research.
Like whenever we see a Tetra Pak, for example, it is a multi-layer film packaging. So there are film layers, polymeric film layers, there are aluminium layers, there are some adhesive layer which are connecting the layers. So these are widely used now. Specifically, I can say this packed food system. it created a commonly trend. Like I guess 10 years back, we were not seeing so much packed material. Now the milk also
Yeah.
comes in a packet. Now a juice
Yeah.
also packet, even the coconut water is coming in a packet. So like that, when we are throwing it, we are not thinking where it is going. And now it's a big threat for the environment when we dispose a polymer. But it's
Yeah.
not only the matter comes as it is a multi-layer. It is having polymeric, it is having some metallic components, some adhesive, some inorganic molecule, everything. When we just dispose it, the people who collects the disposal of any kind of wastage, they just collect it and dump it somewhere else. But what happened, if we want to properly recycle it, the first option is to delaminate all the layers. That
Okay.
itself is another big process. Like you need to delaminate the aluminum from the polymer, then the polymer to polymer. So that is itself is a costly effect. So I don't think so much of Indian industries are still doing it, because obviously it's expensive. How will people bear it? So there is an option. We can either make it a single layer film, which can remove the multi-layer thing only. So we already have a processing window, and we can reprocess it in the same window. And
Okay.
the other option is to reducing the number of layer. Like suppose we are having a 7 layer or 9 layer, which are very common in the conventional market. We can reduce it to 3 layer. The wastage will be less.
Okay.
So that was the target during MTech, and it was a collaboration project with Indian Institute of Packaging, Mumbai. So we both IIT Delhi and IIP together, we have tried to reduce the number of layer, and we have also published a paper in the same. After then, when we were thinking about doing PhD, I continued with the same supervisor. So me and my supervisor were again thinking about doing something environmental friendly, like which can actually show some application in the industry, but in a sustainable way. So the main target of my PhD project was to establish a green and sustainable technology. So that technology we have used for biopolymer processing. So we have also patented the same process, and it can be widely used in industry, this concept. So that is the whole journey of research. I can say the main target was to make something environmental friendly which can be helpful for the society.
I hope people will know about it, and your information regarding the Tetra Pak and the food products, like we're discarding at any dustbin and like anywhere to just throw it. So we have to take care of these things. My next question, like I want to know about what is the basic difference between the industrial research and the academic research?
Seeing its application in the market. And this two kind of research varies from industry and academics. Like the academician are extensively doing the science and engineering, which they are providing an excellent database for the future people to continue the research. Whereas in
So,
they are doing, but in industry they are going more to the application.
okay. So, like, what you will suggest to the youngsters? Like, they should come and join. Why they should come to the polymer science field? Like, what thing it will fascinate to them, so that they can continue the career in polymer science, even if those parents who don't know about polymer science.
I feel one thing is like very common idea about people, polymer means plastic.
Yeah.
And that basic idea, I want to say as a polymer person, that idea is wrong. Polymer does not mean only plastic. It contains it mainly specifies one type of material which is providing specific properties. That's why we came out from a stone age to metal, and metal is replaced by polymer. That is the whole reason. Polymer is a lightweight, it is anti-corrosive, it is eco-friendly, cost effective, and even we can use eco-friendly polymer as well by using biopolymers. That might be in a research stage and somewhere not in a commodity plastic, but it is also used in biomedical field. The second thing is polymer does not restrict you to a single field. Like polymer can be used in automotive. Polymer, I'm just trying to make some career option which grows the interest in the younger generation. First of all, like polymer is used extensively in automotives, interior, exterior, the body of different automotive compound, the aerospace, everything. The body compound is almost 50% is made by polymer now. Then there are tires which are made by rubber. There are composites which makes the aeroplane body, the different body parts of the even you commonly used cars and everything. Other part can be biomedical field, the body replacement, the packaging part of drug, the instruments all are made of polymers, so that can be another option of career. Another option is like the aesthetics, like what we use as a paint, adhesive. This kind of field can be one more option. When we go for a specialty chemical, there is again polymer. So that basic idea of what is polymer, I feel still it is not deeply understood by the younger generation. So that is one of the drawbacks. So if they make their idea very clear, it opens the scope to different industry. It does not bind it to only one industry or one path.
Like what are the industries name? Like we know that only polymer industry, like the rubber tech, they are making some rubbers and some plastics. Like what are the other industries? Like what are the probable chances that you can go into the other industries?
Yeah. As I mentioned, one of the common industries paint adhesive coating. That is a widely used polymer company. Another is automotive, including aerospace. Another can be biomedical. Biomedical, as I mentioned, replacement instruments, both that side. Polymer packaging, that itself another path. And specialty chemical and even petrochemical field, they need some of the polymer scientists there for their particular uses. So I guess the field becomes quite open, uh, from the biomedical to the daily use product. Everywhere we can use this.
Okay. My final question: how polymer science is going to help for the researchers to build their career, and of course, what is the polymer science research contribution towards the society?
After engineering, it becomes more of a technical job, like you are doing just some technology which is already established and you are just repeating it, and you are going to the market. But after doing PhD, I guess it is more about research. So we go in the background of the we are not exactly in the front line, we are going in the background and we are making the building blocks for any company or for any industry to go in the market. Like we are doing some research, we are innovating some new product which can be useful for the society. Even we are improving some of the product as well as process which are already in the market. uh, as I already mentioned, throughout my research career, I tried to work towards environmental friendly way. And if I get an opportunity to work further in the same field, I guess that can be a huge contribution to the society. As you know, currently our India government and the not only India, as an international, if we talk, people are more aware of environmental friendly thing. So this environmental and sustainable, green and sustainable technology can bring a completely new path for a researcher as well as for an industry. The governments are also pushing the industries to do something which is green and sustainable. So in this way, I feel I can contribute to the society.
Yeah, thank you for your contribution and information. We are very proud of you that you did a great work, and researchers are doing something for the society. I hope today's discussion will definitely attract the youngsters to come forward and carry out their career in the research field, of course, particularly in the polymer science. Thank you for joining with us. Wishing you a very bright future. Thank you.